Discord. So when we talk about compounding interest and stuff like that in these accounts, we're just going to make one principal. We're going to make one payment, or one, I guess, shouldn't call it payment. We're going to make one sort of thing of money. We're going to put money down as a principal, and we're not going to make payments in these. And the next chapter is when we start introducing payments. So we will introduce, oh, come on. We will introduce the PMT, I think is what we call it, that variable. So there are maybe a few variables you have to know in these sections in chapter 4. But for the formulas, I will give you the formulas. You just kind of have to know what the variables mean. So simple interest. Calculate the amount of money you will have in each account after 5 years, assuming that the account earns simple interest. So we're going to do a simple interest. I think there might be there is a formula for it, but I generally just calculate the interest. When it's simple interest, I feel like it's easy enough to sort of just calculate it. So if we're going to deposit $800 into an account and it has an annual interest rate of 5%. So if you want to know what interest this thing is earning, it's earning 5% of the 800 every year. So we want to know what 5% of 800 is. And then we're going to do that every year for 5 years. So we're going to do that 5 times. And that will give you your interest. After you have your interest, this is the amount we're starting with. We're going to add the interest to that. And I think this entire section, the thing with compounding and the thing when we get to compounding is the issue is rounding, I guess is what I'm trying to say. Students will always ask, how far do I need to round things? And that depends how close to the solution do you want to be. So this, we might have to actually grab a few decimal places when we start doing the exponents. I would not round things till the end. And if you have technology, like I have a calculator, even my phone, right? You can just recall. It's better to get a more accurate answer. And if you have technology, use that to your advantage. On my devices, I can recall the answer and just use full thing as $1,000. All right, let's go over a quick slide. We'll talk about what y'all probably did. This is what I was talking about. If we have simple interest, we're just taking that interest straight off the principal. So the big difference between simple interest and compounded interest, which is what we'll get to next, is that here we're just taking the interest on the principal of the 800. Simple interest only takes interest on the principal. Compound interest takes interest on the principal and on interest. So compound is like we're taking interest on interest. It'll be a little more complicated than this. But anyway, we're making 40 each year, which means we're doing 200 overall total interest. So if we do the 800 principal and the 200 interest, this should be our 1,000 accumulated amount. Okay, now we get to use some formulas, I think, on the next one. Okay, so this is basically the formula sheet that you're going to have for, it's on your quiz, it's on your test. This is the thing I made up. So I think it has pretty much everything that you should need. We had this first one, we had the second one, we had the third one. We haven't gotten to savings plans yet. So if you're using any of these down here for this section, you're probably doing something wrong. We should probably be using one of these first three. Ooh, I don't know if we even have a homework problem with continuous compounding. Maybe I'm wrong. I don't remember doing one now that I look at it. But you should know how to do that. It's not super complicated. You just have to look at the wording in the problem. If it says it's continuously compounded, we're using the small e or the Euler's number. So compounding more than once per year, use the appropriate compound interest formula to compute the balance in each account after the stated periods of time. So what are we doing? We're doing 4,000 is invested for 20 years with an APR 6% and monthly compounding. And nearest dollar. So if we're looking at this thing, I need something that is compounded monthly. And so this one is for interest paid once a year. This one is for continuously compounded. That is not what they said. They said monthly compounding. And so I think the one that you probably want to use is that middle one. And if it's monthly, what does that tell us about our in variable? So I think I might have said this, but let's go through it again. A in these formulas should be the accumulated amount. That's the amount that you're going to end up with. P is your principal. That's the amount that you start out with. APR is your annual percentage rate. N is the number of times it gets compounded per year, or the number of times it gets solved, the number of times you're making payments will also be it. It's basically the number of times that we're going to crunch it per year. Y is going to be the number of years. I think that defines everything in these top three. Besides, the little e is Euler's number. If you have a calculator, it's probably got a little e key on there. If it's got an ln, a natural log, it's kind of like the opposite operation of the natural log. Okay. So I guess my advice on rounding is you should probably end within you should probably get within $1 of it for this at least. If it's like $2 or $3 off, that's probably pretty fine. It's one of those things that's kind of relative. If we're talking about thousands and thousands of dollars, if we're $1 or $2 off, it's not a big deal. But if I'm talking like $5 and you're $2 off, right? That is you're way off then, right? It's like, whoa. So it depends a little bit how much you got. Okay, let me write out the formula. And again, give these things a try. I don't expect you to be correct all the time. That's why we're in class, but I do expect you to be active and give things a try. 12, 4, and 20 years. I guess the other thing with these formulas is that we have orders of operations. So we got to make sure we're doing orders of operations correctly, doing things in the right order. Don't forget your money signs. Doesn't seem right. But I'm going to do it anyway. What did I get? How did I do it wrong? Oh, did I not? I don't think I rounded my. What did I get? 13,241. Yeah, I should have rounded it up in my notes, and I don't think I did. Yeah, I did it to the nearest whole dollar. If I do these to the nearest cent, there's no way we're gonna probably end up all getting the same solution, if I'm being honest. It's just easier to round things to the nearest dollar in this section. But this is the formula that you should be using. If we know it's done monthly, this is the formula. And for the most part, if we go back and look at that formula sheet, this one and that first formula are really kind of the same formula. We just let n be 1, and then this formula will actually become that first formula we introduced. But that first one's a little bit easier if you don't have to do this one, right? I guess. Principles 4,000. What else am I plugging in? The rate is 0.06. I'm dividing by 12. I'm doing 12 times 20 up here. So order of operations tells me I have to do this division. I have to add that to 1. I can multiply these things as well. So you're going to have to do these, and it looks like most of the people here, so I feel like I'm maybe preaching to the choir a little bit, but you're gonna have to find some sort of device that does exponents for this test. So 1.005 to the 240. Okay. And if we do that, I get something like 3.310. Multiply that by 4,000. That's where we're getting the 13,240, 81, 82, 13,240, 80 that you were getting. So that all depends where you round this thing. So my advice is don't round it. Definitely don't round it until maybe to this last point. I would definitely keep as many decimal places as possible. If not, raising things to exponents really throws things off really quickly if you start rounding it before. So definitely my advice is don't round it before you start taking exponents. None. Not at all. Find the APY. So this is, if I'm being honest, this is not something I would know just probably off the top of my head if I didn't go back through this course and like read how to find this thing. But it's not super difficult. It fits in with all the other concepts we're learning. It's just kind of remembering what it is. But it is the annual percentage yield. And basically you find the annual percentage yield by going for 1 year and seeing how much it's going to go up. And so we take a relative increase is what we want to figure out. So the APY is the relative increase for 1 year. In this one, they give us a bank offers an APR of 3.2% compounded monthly. So we want to figure out, they don't give us a principal. So you have like a few options. You may not always get a principal if they're asking for APY. So you can kind of let the principal be whatever you want it to be. There's a few numbers that I might want it to be. 100's a really good one. Another one, maybe 1. Whatever number you pick, basically, you should be getting the same number for your APY. So pick a P. Go plug your principal back into this equation here. And we want to plug it into this equation to find our accumulated amount. After we find our accumulated amount, we do the little A minus P over P, the relative change, to figure out our annual percentage yield. So what this is sort of like asking is like, if this wasn't compounded monthly, right, is what this is sort of like asking. This is compounded monthly, but if it wasn't compounded monthly, if we just compounded it like once per year, what would that rate be? What would our sort of yearly rate be? Because we know the yearly rate, if our APR is 3.2 and it's compounded monthly, we know our yearly rate would actually be just a teensy bit higher. Yeah, I think that's what they're saying. They want us to round it to point, the nearest 0.01%. So 2 decimal places. Okay. Ow. 'Kay, where are we at? 3.25. What else we do? Yeah, I don't know where that 5.2 is coming from. Maybe it comes from rounding this or something. Bank offers what? 3.2 compound monthly. So I think what I did is I let my principal be 100. So if I let my principal be 100 and I plug it in, I got something like 103.24735. And I let my principal be 100. It's a little bit of a gimmick, a little bit of a trick. But if I let my principal be 100, I have to subtract 100 from this, and I'm pretty much there. If you let it be 1, I think we get the decimal, and then we just have to convert it to a percentage. If you let it be 100, then it's already at a percent. So, questions about that? The person that said 5.2, I'm not sure exactly what you're doing, but hopefully you know. Any questions? If not, we will continue. So that is finding APY. Planning ahead. So how much does it? Ooh, so this is a little bit different from what we've been doing. So this is going to require like a little bit of back solving. How much must you deposit today in each of the following accounts in order to have? We want to have 25,000 in 8 years. To make a down payment on a house. Okay, that's not really too important for the math part. But assume that no additional deposits are made. That would be this section. If we were making more deposits, then that would not be this section. That would be the next section. An account with monthly compounding and an APR of 6%. So, gonna point this out. This 25,000 is not your principal. That is how much we want to have in the end. That should be your accumulated amount. So, going back to this, I believe we're doing monthly compounding. So anytime they tell us monthly, anytime that they tell us anything that is not once per year, or anytime they tell us anything that is not, what else, continuously compounding, it's probably going to be this formula. We're going to use this formula probably a bit more than these other two, if I'm being honest. But you might use the other two, so they're there. So I kind of mentioned this, but we don't have principal. We have the accumulated amount. I can fill in accumulated. I can't fill in my principal. I can fill in this. I can fill in that, the other. I'm going to want to have to solve for my principal. My principal is being multiplied by this, whatever the heck this is. But I can fill all this in, and I can figure out a number for this thing over here. So principal times some number is going to give me my accumulated. If I want to back solve and all this is being multiplied, the thing that undoes multiplication, the undo operation, inverse operation, should be what? Division. So there should be some division, like the last step defining it should be division. To plug in the numbers that they give you from the problem into this thing. So we know we want to find what? 25K. I have no clue what my principal is. I know the number one is still just the number one. I know my APR here is 6%. Is that what it was? Let me bring it up. Where did I go? Yeah, 6%. Okay. I know it is compounded monthly, and I know I want to do it for 8 years. So I think that's all the information I need to plug into there. And round that guy to the nearest whole dollar. There we go. 15,488. What are y'all saying? 15,488. That's it. Okay, you just gonna put some extra cents in there. That's good. Okay, so hopefully you're using your pencil, paper, calculator to solve these things and not just throwing them in. I'm sure Google has some sort of formula or something for these. But you're not going to be able to use that on your test. So hopefully you're getting some practice in actually solving these by hand somehow. But that's the formula we're going to use. We're going to plug in all the information. So this was what I was telling you. We get the accumulated amount, not the principal. So we get the principal, and it's multiplying by all this stuff. I can do some order of operations. I can divide these things. I can add them. And so I'm probably just going to like jump from this step to this step quite often. It's like we divide this and then we add it to 1. I'm basically going to have 1 and whatever the heck this decimal is over here. The other thing is what 12 by 8. I can multiply those two things. And now I have a number raised to another number. I have to have a calculator of some sort to find this thing. But we plug this into a calculator, we get a number, and I kind of hinted if this is P times this number, we have to divide. So 25K divided by that crazy long number. And a lot of the stuff I rounded it on the quizzes, but like I didn't round it in my calculator. So these things may not match up exactly, but like this should be the exact solution, if that makes sense. I believe that gives me exact solution. Or rounded, whatever it is. So a lot of these numbers were really long, and I didn't paste the whole number in there. That's basically what I'm just saying. I had to cut off a few decimal places, but the solution should be accurate. I didn't round it anything when I put it in my calculator. Any questions? Oh man. Okay. Yeah, and if I'm being completely honest, this is probably not my most favorite section. And part of that is that like I feel like a lot of this stuff, there's a little bit of thinking. It's like, well, what formula do I have to use, right? But a lot of this stuff is like you put it in the formula and it's order of operations. Can you solve it in crunch numbers? I don't feel like there's like a whole lot of critical thinking with crunching numbers, right? It's more like, do I understand the system of math and like the sort of, what do I want to say? It's more conventions than critical thinking, I think, right? Which is important. Don't get me wrong. But I like the problem solving stuff personally. How much must you deposit today in each of the following accounts in order to have a 120K college fund in 15 years? 2 new additional deposits are made. And so I think, let me finish reading it. An APR of 2.85% compounded quarterly, and run it to the nearest dollars. But I think the important thing is we have what? 120K college fund. We have 15 years. APR of 2.85. And this quarterly, this is different now. It's not compounded monthly, which would be 12. It's compounded quarterly, which there are 4 quarters in a dollar, in case you didn't know that one. But yeah. And so this looks very similar, hopefully, to that previous one. So if you didn't get that previous one correctly, which I think everyone did, here's another chance. I think the other thing is they do what, quarterly? That's a little different. If I'm being honest, I guess this happens. But usually we're going to compound things monthly. Typically things get compounded monthly. If you're going to make payments, you typically make monthly payments. And so if we're talking about savings plans or loan repayments, typically those things are compounded or paid monthly. No, this is just not hitting. Huh. Need a refresh. Is it gonna go through? All right. Mm-hmm. Did I do it right? Make sure. Where we begin? 78375. That looks good. What else are we doing? Rounding it? Is it a rounding thing? Yeah, okay. And there's dollar. All right, so this is probably what you did. 120K is going in my accumulated amount. My interest changes to 2.85%. I'm doing it quarterly, which is this one, my in, for 15 years. So 120K, I'm going to do this number, divide that, add it to 1. I should get this crazy decimal. I'm doing 1.007125 to the 60th. Got to do exponents there. I think the most common thing is like sometimes people will multiply their exponents for some reason. It's got to be raised to that number. And then the last thing is we're going to divide those. And we should get 78,375. That's it. And so following pairs of investments are identical except for a small difference in interest rates. They want us to compute the balance in 10 years and in 30 years. So we have 4 different things to calculate here, I think is what they're telling us. So Chang invests $500 in an account that earns 3.5%, and it is compounded annually. Keo invests 500 in a different account that is 3.75%, and it is also compounded annually. So like they said, the only difference is this 3.5 and this 3.75. But if we want to go for 10 years for Chang, and it is compounded annually, you might be able to save yourself a few steps if you use the right formula. If not, you might have one extra little step. But again, I think we want to know the accumulated amount. We know his principal is 500. We know the interest rate for Chang, which is the first one we want to do, is 3.5%. And we know we want to go first for 10 years. So first we're going to figure out what Chang has for 10 years. And then the next problem, we're going to figure out what Chang has for 30 years. And then we'll figure out what Keo's is. So these should all look really sort of similar. We're just changing sort of like one number at a time, I think is what's happening. Okay, nearest dollar is what I want to do. So hopefully I did this correctly. I did it really quick. That seems What did it do? Maybe it was the other one I was thinking about. So again, I think we're doing Chang for 10 years. So the principal is 500. My interest rate is 3.5%. And I want to go for 10 years. So if you use the right formula, that should be all the information you need. 500, 3.5% in 10 years.
Wait, so for this question, we put how much after 10 years for?
Yeah, so how much does Chang have after 10 years? And then the next thing is we'll figure him for 30. And then we'll go to the other guy. So this one has 4 different parts to it, basically. But if we get this part down, like the other one should come pretty quick. We're just changing one number at a time, sort of thing. Oh yeah. Is that required, Stephanie? And I'll give you a hint. Like if you use this first voice formula, okay. If you use the first one, it will probably be a little bit easier. I guess you could use the second one. If you let n be 1, you get this formula right back. And so what was that? 705 is what I got. So what you're arguing? Potato Othello. Are you smarter than a potato? That's what you get to see today. Oh man. What are y'all doing? Rounding stuff to the wrong place? Is that what's happening? 723. I think you might be looking maybe at the. I don't want to say too much, but I think you might have like swapped up the numbers. I think you might have did the other percentage. This one should have been the 3.5%. So use that first formula. We do 0.035. So this is 1.035 to the 10th. Should give me this number. I multiply it by 500. And so this is what it should look like for 10 years. And you can guarantee I copy and pasted the slide. For the next one, for 30 years, what should it look like? There's like one little change we should make, right? I think it's right here. Okay. Yeah, I guess that's kind of my advice to you is to write out these formulas, write them out neatly. And a lot of times you might figure out that like if you're replacing one variable, you might be able to solve yourself a little bit of work, right? That makes sense. Sort of like in this one. Okay. It should be 1403. What are y'all telling me? 1403. 1404. Okay, good. Okay, so this is the same thing, but now we're doing 30 years. So instead of 10, it is 30 up there. We get a different number that we multiply by 500. But it is 1403, 1404 is good. And so now the same thing, but now with Keogh. And so how does that change? Well, we're going back to 10 years. So that T should be 10. My R changes to 0.0375, I believe is what it changes to. Ooh, don't forget your dollar sign. I know what this one is because I answered it wrong. Double check. Oh man, I should have rounded it up. And it didn't. I think I might have put them in. For some of these, I put like the closest $2 in or something like that. I try to be kind of lenient, whether you round up or round down, because it all depends how far you round your previous stuff, you know. So you should round. You shouldn't round things too much to where it becomes too far off. But we're not all machines. We don't want to carry all those numbers. I understand a little bit. But this is what we're getting. It looks very similar to the previous one, except now this instead of 0.035, it's 0.0375. And so the last one is going to be Keogh for 30 years. So you might have figured this out. It's 404, right? We're in 304. But what, 10 becomes 30, I believe is what I'm saying. And the last one we need to figure out. And then we can talk about this. And compare and contrast and do all that sorts of things. 15. Okay. And so basically what they're trying to get you to do is they're trying to get you to like kind of manipulate this formula sort of variable by variable, I think is what they're trying to do. What happens if we just tweak that rate just a little bit? That's not what I wanted. It is what I want. What'd y'all tell me? 1509. Did you round it down? 105. No, we're getting that. Okay. I don't see that. This was Keogh. This is the last one, so it looks very similar to the previous ones we did. But now we're raising things to the 30th. Maybe you divided that last step. I don't know. Okay, and then this is the last question I think that they have on here, sort of. It's like, what does it say? Chang versus Keogh, and so they want us to sort of describe what's the difference here. So just sort of looking at this. Remember, Chang has a 3.5. Chang has the lower one, right? And Keogh has the higher APR. So they're trying to sort of isolate the APR variable is what they're doing. They're holding everything else constant, and they're just tweaking that one variable. And so if Chang has a lower APR, what we notice after 10 years is I think Keogh is a little bit higher, right? And so if we look at this, I think what the book did was give me the relative difference between these numbers. So if we're looking at these two, and let me crunch this right quick. Where's my text? So if I'm looking at relative difference, between these first two, if I do 722 minus 705 and then divide those, this is what, 2.44% or something like that. I think what they did was relative differences. We can look at relative difference. These would be the ways that you'd probably want to compare these two things, is looking at relative difference and looking at the absolute difference. 140340. And this is what, 7.5% difference. And so what is this sort of telling me? That's not what I want to do. I want to move this over. Where did I? Is that what they did? Oh, yeah, I didn't say anything. That's right. This is a open-ended question. I'm going crazy. But full question view, that's where I was. I was looking at it here. This is where I was. Sorry. So I think this is what, 7.22 difference. Trying to hit the right key here. But if I want to do, this is my relative difference. If I want to do absolute difference, this one is 17.22. So what do you notice about these, about their relative difference, about their absolute difference? Absolute difference here is 105. So what do you notice about these things? So you're talking about maybe $17 difference in 10 years. But when you get to 30 years, you're talking about what, $105 in difference? And so they're not too far off, right? It's like 0.25% difference here. And so I think the thing that they want you to notice sort of here is that in the short run, they're going to be kind of close, but the longer that we go with this thing, right, the further off that little percent difference is going to make. So if we take 0.25% and we take it for 1 year, it's not going to make a big difference. But if we keep doing that 0.25% and we keep doing it year after year after year, it's going to build up eventually, is what this sort of tells me. Are y'all seeing that? Is that making a little bit of sense, hopefully? Okay. Let's clear all them drawings. Yeah. So you probably won't see much of a difference, yeah, in the short run, but like longer run, it will get more and more off as it goes. So in the 10 years, they're fairly close. They're like 2.5% off or something. But in the longer run, they're more like 7% off, right? That's pretty substantial when you're talking about money. Like if you got $500 and someone takes $20 out of it, it's like, yeah, I'm gonna notice it, but it's not a big deal, so to speak. If you got $500 and someone's taking $100 and something out of it, you're gonna notice that pretty quick. Okay, so full question. Next question. I think this might be the last one or second to last one. We're getting pretty close. So your bank account, find the current APR, the compounding period, and the claim APY for your personal savings account, or pick a rate from a nearby bank account if you don't have one. This is definitely the last one, I remember, because I had to look up some stuff for it. So what I did is I went to my credit union and I looked up this ad that they have. And they had some words that were small, but these were the words that were in bold. They had 3 different claims. They said all our savings accounts have these qualities to them. They're like, they all have these qualities. And so the first thing they told me was I have 0.10% interest rate paid monthly. And you got to love this wording. Don't do that. Gotta love the wording here, but they say up to 1%. Why does it keep doing that when I highlight it? Don't do that. Okay. It says up to 1% APY. And it says $0 monthly service fee. That's not something we're really concerned about, but these are the two things I really want to look at. So I want to calculate the APY on this account. Does your calculation agree with the APY claimed by the bank? So this one, they wanted you to go look up your own bank account, but I wanted us all to be kind of on the same page. And I was trying to figure this out, because if I really wanted to find it, I could go find the APR and I could go find the APY of each of their accounts. But it was definitely in there, if I'm being honest. Like, it was definitely buried in there a little bit more than this thing. This thing was bold. It was really graphic. It had those 3 bold fonts, and it told me these 3 things. And so these were the things that they were really advertising for their 3 accounts. And you can probably tell already, right? If they're saying up to 1% APY, do you think they're getting 1% APY? Probably not. So I want to figure out my APY. And I want to figure out my APY for something that is what? 0.1%. And so if I get paid 0.1%, this is the A minus P over P thing again. If I'm getting 0.1% monthly, what is my APY of something like that going to be? And so this goes back to like that second problem with finding APY. I have to find basically the relative difference for 1 year. Don't forget to add 2 more zeros to this guy. And so what do you get if you try to do that? Has anybody done it? So it might seem like a bit of a trick question, maybe. I'm not sure. But if my APR is what? 0.10%. What is my APY? If you just tell me what the APY is, I would be happy.
I'm kind of confused on what we're supposed to do. So Because I found the APR, but I don't know what to do after that.
So the APR is 0.10%. Is that what you're saying? Or the APY?
Would you have to multiply that by 12?
So you have to do the accumulated amount, right? Equals 1 plus the R, which is 0.001 over what, 12? And we're raising that to the 12th. Or 12 times 1 maybe. But it's just going to be 12 up there. And what happens if we do that? And I guess we do a principal of 1, or we do principal of 100. But you're going to want to do what? Accumulated minus principal divided by principal. And maybe it's a bit tricky, and I'm saying it's a bit tricky. Because what do you get if you do this? I'll give you a hint. It doesn't change. So if you do plug it in and you do get your APY, it's not going to change at all. Which is why I feel like a lot of this question seems silly, and it's an even question where they make you do your own research. So they definitely don't have solutions in the back of the book. But I found an account and we can do something with it. So let's do it. If I want to figure out my APY, if my APR is 0.1, oh, that should not say 0.1 in there. That should definitely have 2 more zeros up in there. But you might notice it's not going to change it at all. I'm going to get basically this 10% right here is coming off of this decimal place. So I'm getting everything here that's not 100. I'm subtracting 100 from that. Someone's saying something. I thought I saw something pop up. Okay, never mind. And so I get like 0.10004%. Like it's adding like such a little fractional amount. Is a little bit more than 0.1%? Yeah, probably. But not, it's not enough to even really do anything, right? It's not enough to change that percentage at all when we round it to 2 decimal places. So it is not very much. It's about the same rate. And so that's why I feel like it's a bit of an odd question, but this one is doable. So suppose you receive a gift of $10,000 and you put it in that account. Your interest rate doesn't change. How much will you have in 10 years? So this is fair. Ooh, excuse me. We want to do an APR of 0.10. This is done monthly for 10 years with a principal of 10,000. So I think that falls all into our formula. Should be able to put that in the formula. And remember, put 2 more zeros in this thing. We're moving it 2 more spaces to the left. So we're definitely not getting that 1% APY that they're talking about. And I think what they were saying is, it's really deceptive, right? Because if they say up to 1%, if one of their account gets 1%, I think that's what they're saying. It's definitely not this account that's getting the 1% APY. So they kind of cover their asses with that, like the up to part, right? Like this could literally be like anything, as long as one of them gets one. This could be like, this could be a one billionth of a percent. Technically, that statement would be true, right? It's like that doesn't tell you anything. All our accounts get up to 1%. Okay, what's the minimum though? It's like the maximum is 1%. Great. Okay, so this should be all the information you need, right? Principal of 10,000. The number of years is 10. The number of times it's compounded is monthly or 12. And I have an APR of 0.1 or 0.001 if I want to convert that to a decimal. Okay. Should be finishing this up. Did you get 10? Did you get 100? Did you get 10, 100? I think it's 10,100, right? Is what I got, something like that. What are you telling me? 10, 100. Come on, Scrolly. 10, 100. Woo, that's high. I'm trying to see what y'all did, but I'm not sure. All right, so let's see. This is the formula you should be using. Principal is 10,000. My interest rate is wrong there again. It should say 0.001. I copied and pasted that, I guess. Divide that by 12 and 12 by 10. Where did you go? There it is. So again, just to highlight, this should not be saying this. Just say 0.001. All right, you should get that number. We'll raise this number to the 120, multiply it by 10,000. That should be where we're getting the 10,100. Any questions about this? Okay, so it definitely seems maybe like they're being a little bit deceptive with that 1% APY dangling out there. Suppose you could find another bank account that offers savings accounts with an APR that is 2 percentage points higher than yours. Same compounding period, same everything else. Briefly, don't do 2 whole percentage. I feel like doing 0.3% would be better. And so I want to try doing it with 0.3%. So instead of doing 0.1%, how does this come out if we do 0.3%? We added 2 percentage points. That'd be 2.1%. We'd be going from 0.1% to 2.1%. You're not going to find savings accounts with whole percentage points. APR, I think the highest one I saw was 0.5%. Like, I don't know why they would add 2 whole percentage points. It's not. It's going to be insanely high compared to the previous one. Oh, connection lost. Okay, so doing same thing we've been doing. 10,000 is my principal. Do 1 plus. My APR here now is 0.3, so it should say 0.003. I am doing this monthly, so my N should be 12. My N is 12 again up there, and I want to do it for 10 years. Divide, add, multiply, raise the base to the exponent, multiply again. So this, if you're here today, you're taking the good first steps to getting the stuff down. They're going to get more complicated from here, right? So knowing how to do these formulas, the more you do these formulas, the easier they sort of get. So again, like, I don't know, I tell you all this, but like, I think for the most part, the people that are coming to class are kind of, at least taking the right steps in the right direction to being able to pass this class. What was I saying? I fell asleep. But yeah, I feel like a lot of people are dooming themselves. I don't know what they're expecting. If they're expecting to pass the class by not coming to class, I think they're going to be disappointed. I can't force you to do anything, right? You're an adult, you're in a college class. If you want to sit through a class and not do anything, or if you don't want to come to a class, congratulations, but don't expect credit for that class. And maybe it's just hard because I've been there. All right, so I don't know who's trying to make this last forever. And I understand we all have lives and we don't all have, like, can't always dedicate it all, but like, I think my big thing is like you have to take a little bit of personal responsibility, right? And if you're slacking in your classes, you have to take responsibility in that and say, hey, I didn't do this class like I should have done this class. I don't really understand. Well, I guess I kind of understand it. I've never done it personally where you like kind of project your own failure. You're at your professor. It's like, if I didn't go to a class, I definitely didn't blame the professor for not passing the class. Man, I am not trying to stay here until after whatever. I don't know what y'all are doing, but that's the last one. Come on, Carla. Oh man, I'm not trying to stay here all day. This is the last question. And so if we go from 0.1% to 0.3%, we get a little bit different number. And we raise that to the 120. We get a bit different number. But this is giving me 10,304. Did I end that one? Because I didn't feel like I got that number. Did I do that correctly in this one? To the 120. And I want to multiply this by 10,000. No, that's right. I don't know if I did. I didn't end it is what happened. I think I did this wrong on my notes. Okay. Yeah, I did it correctly here. I think I did it wrong when I did it earlier. I don't think I multiplied by the right number, but there we go. So how does this compare? I think we had 10,100 before, and now we have what, 10,300? So when we went from 0.1 to 0.3, I think we went from $100 interest to $300 interest. And that is the last slide, I believe. That's it. If you have any questions, I'm here. If not, be prepared to go through 4C on Thursday. And then we'll finish up with 4D. So 4C is all about savings plans. And then we will go into loaner payments.